Cassandra and Eastwell. So this is like my first time attending the NGCC, so a lot of good talks, right? Very excited. A little bit about me. So I'm a software engineer in Eastwell. So when I joined Eastwell from Facebook, I worked on like different things, various things to keep Eastwell the site is up. And right now, like as the team grows, now I'm putting more time on providing Cassandra as a like general key value database for Eastwell usage. So today I will talk about like three things. So first I will give an overview of like how we use Cassandra in Eastwell by giving some like typical use cases. And then I will talk about like the improvements we have done to make Cassandra like to improve Cassandra to make Cassandra to be able to meet our product needs. And then I will talk about some challenges we are still facing, and we are looking forward to hear feedbacks from the community, and we are also looking forward to solve them together with the community. So for the overview, so here are some numbers for the Cassandra cluster in Eastwell. So we have like thousands of Cassandra nodes. The total data size is like hundreds of terabytes, millions of operations per second. So the largest cluster, we have hundreds of nodes, and we're running cluster across multiple regions. So I can see multiple here. And for the client, so we support the access to Cassandra from like all different languages. And for our clients, mostly they are using like Swift, and we're moving, looking forward to moving to secure. And we're using like 2.0, 2.1, we're using the level connection. As the Cassandra cluster grows, the Cassandra team also grows. Like when we first introduced like Cassandra into Eastwell, just like less than one employee full-time working on Cassandra. Like as we put in more use cases on Cassandra, like we started to have like 1 or 2 people working on Cassandra like last year. Like this year, since we are like putting one more critical use cases on Cassandra, so like we have around 5 to 6 people working on Cassandra. So I will give some like typical use cases. This is like for Eastwell feed. You might know like for Eastwell, like we're doing the feed in push model, yeah, almost push model. So like when a celebrity or like any user posts a media, we will deliver the media to his inbox. So that means the write QPS is very high, like we have millions of QPS. And for each read request, we will read like hundreds of medias from users' inbox. So the average MP99 reading latency are 20 milliseconds and 100 milliseconds. So the data model is very straightforward. Like each row in Cassandra represents user's inbox, and we are storing the list of medias, basically users' feed in the columns of that row. So this one is like a typical, very big use case. Also, we're using Cassandra as like metadata storage for a lot of use cases. This is again, this is a typical one. Like we have like more than 100K read and write QCS. The average read size is around 50 kilobytes, and the latency is like 7 milliseconds for average and 50 for P99. Again, the data model is like very straightforward. Each row represents the metadata associated with one user, and we are storing a list of blocks in the columns. So those two, those are typical use cases, and then I will talk about some improvements we have made or some changes or configure tunings we have made. So first one is like we call it proxy node. So the problem was that because our clients are based on Swift, which is not token aware. So that means the client will randomly send the request to some data node. And the data node will need to coordinate the request to the correct record. And we often saw that when the data node was very hot, like doing compression, the client request latency will jump a lot and even timeouts. So we solved the issue by introducing a separate tier of Cassandra instance. They are also running the same version of the Cassandra, but with the settings like join ring to defaults. That means the proxy node, they do not store any data locally. Instead, they just act as the coordinator for the client request, and we configure the client only talk to the proxy node, so that we can separate the nodes of handling client requests from handling the actual data. So after deployment, we see like 2x latency drop. The second one is about the pending range. So that is ticket number, dual number they are. The problem was that like when we bootstrap, like when our cluster grows to like certain size, and then when we bootstrap a new node into the cluster, we saw like significant CPU usage increase on the whole cluster, especially on the proxy node. And also for the client requests, we see big latency jumps and even timeouts. We wondered why, and then we dig into the code. We found that Cassandra was using a multi-map to store the mapping from moving tokens to the new node. And for each request, Cassandra needs to perform our own lookup for the pending tokens, which is very inefficient. So we created the ticket and we solved the issue by using two navigable maps to implement the pending range, so that we can reduce the time complexity for the lookup from O1 to O11. So that means we can expand or shrink the cluster anytime without affecting user requests. Here I want to thank Brandon for the patch review and the feedbacks. The next one is about the dynamic stage. I think Nate also mentioned this one before. So the problem, we often saw read latency jump a lot, especially during our traffic time. And after tracing the requests, we found a lot of requests are routed to different region, even though there is a live local region copy. So yeah, as mentioned in the Jira, we found that there was a dynamic SNITCH, which will help Cassandra to decide when to route requests to remote region instead of local region. So here this is kind of a hacky solution that we set the bandwidth threshold to be very high, like 50, so that basically we restrict most of the requests to local region, and we see 10x latency drop. It was huge for us. Also, we are using big heap size, so we use 64 max heap size, and we use 16 gig region size. We also bumped the max tuning threshold from, I think default was 1, and we bumped to 6. So after the changes, right now the NGCC happens every 10 seconds. I think we can probably still improve that, and we can avoid the 40 cost, and we even see 2x latency drop after applying all these settings. The last but not least improvements is about the NODETOOL review. The problem was that we have some data nodes which host terabytes of data. So when we bring up new region, when we run the new review, run the NODETOOL review on the new nodes, the NODETOOL review will take several days to finish. And some of them even fail in the middle or at the very end. If we run the review again, it needs to restring all the data, so which very likely failed again. So we created a ticket and made a change to the NODETOOL review command to support to only review the failed tool images, so that we can avoid restreaming all the data. And here I want to thank HEAP for all the patch review. So those are the improvements we have done. Those are the major improvements. So and right now we are still having a lot of challenges. Some of them might be related to ongoing work by the community, and some of them may not. So I'm looking forward to hearing the feedback to come the solution together. So the first one is we want to continue to reduce the P99 read latency. So this is the histogram one data node. So you can see like the P99 latency is 20 milliseconds even on the data nodes, which means it's even higher on the client side. So we want to continue to reduce the read latency. The second is that the compression often has difficulties to catch up, especially when we run the repair. Here you can see like a lot of backlogs in the L0 and L1, which had an impact on the read latency as well. Also, like we found that the compression is using too much CPU. Here is an example, like it is using like more than 40% of CPU like on the data node. So I know there are some like patches or JIRAs for 3.0. So I plan to like post them to like 3.1 or 2.2, which were mainly using C. If that, if those patches will help with the compression to increase the compression throughput. Also, we want to improve the way like that Cassandra handles the tombstones, so that like for the read request, we can avoid like scanning like thousands of tombstones, which had an impact on the read latency as well. And then it's about the gossip. So as our clusters like grow bigger and bigger, we start to see a lot of problems with the gossip. So we already created several tickets. So this is one problem. This was one problem we had, that different nodes see inconsistent range of the cluster. Like for on the body node, it saw like some of the nodes are in data center D1, rack R1, which is totally wrong. And instead on the good node, it should see the node in data center, for example, FRC and rack, for example, FRC05. So the problem with the inconsistent range is that the bad node will return like incorrect data, basically nothing to the client. So which will cause like inconsistent result on the client side. So we want to fix the gossip, and maybe there are already some fixes in 3 something. Yeah, I'm looking forward to improve the gossip. And then about the counters. So Instagram has a lot of potential use cases on counters. And at this moment, we are evaluating the counters in 2.2. I think overall it looks good so far, but there are still some problems, especially when we run the repair. Like for this one, when we run the repair on the counter cluster, we started to see like error spikes on the client side, and then we start to see like a huge number of access tables backlogs in the LD. So we want to improve the context with the community, so that like we want to provide the context as the solution for each one. For client, so like in Instagram or in Facebook, we have different stacks. Like we have Python, which is mostly used in Instagram. We also have C++, Java, and Facebook's version of PHP. So we do not want to maintain a fat client for each language. Instead, so right now we are trying to build a service layer, which would expose Swift interface to all the clients, and then the service layer itself will use the native protocol to talk to the cluster, so that we can unify the interface for all different languages, and we can keep the logic in the very simple in all the client sides. So I'm looking forward to hear if there are any like existing or alternative solutions. Also, we have some problems with the operations, especially the extensions. So this one is probably mentioned before. Like one, it took very long time to add new nodes into existing cluster. So for example, for this one, we want to expand the cluster like by adding 30 nodes. It turns out it took us like 15 days to finish all the bootstrapping of the new nodes. So we definitely want to improve the efficiency of the bootstrapping. We want to be able to expand the cluster as soon as possible. As a recap, I think we are still, we are still kind of new to the community, and we just started the engagement with the community. And we right now we already made some improvements. We still have a lot of challenges, so we want to have more connections with the community, with you guys, and we want to solve the challenges, the improved standard together with you guys. Yeah, that's all. Any questions?
Yeah, thank you. We're going to take a half-hour break in the Victorian room, which is where we had lunch.